Although it might sound like science fiction, China's Chang'e 6 mission just made history. On June 25, 2024, the mission returned the first ever samples from the moon's far side, landing flawlessly in Inner Mongolia. These samples promise to reveal secrets about the moon's formation and the early solar system. The Chang'e 6 mission, launched on May 3, 2024, aimed to collect samples from the far side of the moon, a region never before sampled. The mission's re-entry module safely landed in Northern Inner Mongolia, China, on June 25, 2024, around 2 p.m. local time. This successful landing marked a significant achievement for the China National Space Administration, CNSA. The mission involved several complex stages. First, the lunar module landed in the South Pole Aitken Basin, an impact crater formed about 4 billion years ago. This basin is one of the oldest and largest impact craters in the solar system, making it a site of immense scientific interest. Using a drill and a robotic arm, the module collected up to 2 kilograms of moon dust and rocks. These samples were then transferred to an ascender, which lifted them off the lunar surface. The samples were subsequently transferred to a re-entry vehicle in lunar orbit, which traveled back to Earth. The re-entry process was particularly challenging and critical. The re-entry module had to undergo extreme temperatures and speeds as it entered the Earth's atmosphere. It was equipped with a heat shield to protect the valuable lunar samples. Upon nearing Earth, the module deployed a parachute to slow its descent, ensuring a soft landing. The live stream of the module's landing showed a flawless touchdown via parachute in the designated zone in Northern Inner Mongolia. This moment was greeted with applause in the mission control room, a testament to the careful planning and execution by the CNSA team. The successful retrieval of these samples underscores China's technical prowess and marks a significant milestone in its space exploration efforts. The search team located the module minutes after its landing, ensuring the prompt recovery of the samples. The module was found intact on the grasslands, with a Chinese flag beside it, symbolizing national pride and technological achievement. The Chang'e 6 mission's complexity and success have been closely followed within China and globally. Images of the lunar lander displaying the Chinese flag and the character Chang'e drilled into the lunar surface went viral, symbolizing national pride and technological achievement. This mission not only demonstrates China's growing space capabilities, but also sets the stage for future lunar exploration. The samples collected by Chang'e 6 are poised to revolutionize our understanding of the moon and the solar system. These samples come from the far side of the moon, specifically the South Pole Aitken Basin, a region that holds clues to the moon's and Earth's early history. The far side of the moon, unlike the near side, is covered in craters of various sizes and ages. This site lacks the lunar mare, the dark plains of cooled lava seen on the near side. The unique geology of the far side provides an unparalleled record of the system's early years. Researchers are particularly excited about analyzing these samples because they could offer insights into the moon's formation and evolution. The absence of plate tectonics on the moon means its surface preserves a record of ancient events that have been erased on Earth. Understanding the composition and history of these samples can shed light on the processes that shaped the moon and, by extension, the early Earth. Furthermore, the samples could help scientists explore the potential for resource utilization on the moon. Elements like helium-3, oxygen, and hydrogen found in lunar soil could support future lunar exploration. These resources might be used for 3D printing construction materials or generating fuel for long-term missions. The international scientific community is eagerly awaiting the analysis of these samples. Collaboration between Chinese and international scientists on the Chang'e 5 mission has already yielded significant discoveries, and the Chang'e 6 mission promises even more. The data gathered will not only enhance our scientific knowledge, but also support future lunar and space exploration. Chang'e 6 is a significant milestone for China's lunar exploration goals, covering the way for future space missions. China plans to send astronauts to the moon by 2030 and set up a research base at the lunar South Pole, an area believed to contain water ice. The success of Chang'e 6 shows China's ability to handle complex space operations, which is crucial for the planned manned missions. Lunar exploration is becoming increasingly competitive on a global scale. The United States, through its Artemis program, aims to return astronauts to the Moon by 2026. This renewed focus on the Moon is due to the potential scientific and economic benefits of its resources. NASA Chief Bill Nelson has emphasized the strategic importance of the lunar South Pole, highlighting the competitive nature of this attempt. China's space ambitions are part of a larger trend of growing interest in the Moon. Countries like India and Japan have also launched lunar missions recently. This competition underscores the significance of space as a field for scientific discovery and national prestige. The Chang'e 6 mission also showcases the potential for international collaboration. While space exploration is often seen as competitive, the scientific community values sharing data and resources. The samples returned by Chang'e 6 will be analyzed by Chinese scientists and then made available to international researchers, fostering global cooperation. Looking ahead, China's upcoming Chang'e 7 and Chang'e 8 missions aim to explore the lunar South Pole further and test technologies for utilizing lunar resources. These missions are crucial steps towards establishing a sustainable human presence on the Moon, which could serve as a springboard for deeper space exploration. The successful return of Chang'e 6 marks a new era in lunar exploration. This mission not only advances our understanding of the Moon's far side, but also demonstrates China's growing capabilities in space exploration. The samples collected will provide valuable insights into the Moon's history and potential resources, supporting future lunar missions. China's ambitious plans for lunar exploration, including sending astronauts to the Moon and building a research base, reflect a broader global interest in the Moon. As countries around the world ramp up their lunar missions, international collaboration and competition will drive scientific and technological advancements. The Chang'e 6 mission is a significant milestone, and its success paves the way for exciting discoveries and future explorations. This mission not only advances China's space capabilities, but also contributes to the global effort to understand and utilize the Moon's resources. The potential for scientific discoveries and economic benefits makes the Moon a valuable target for exploration. The competition among nations to explore the Moon highlights its importance as a new frontier for scientific research and technological innovation. That's all for this video.